Hey guys, hello everyone and welcome to the channel. So in this particular video, we'll try to solve questions from TIFR GS 2022 exam, which was like the exam conducted in the month of December itself. And the questions here are total 40 questions were there in the question paper. I have tried to solve around 30 to 32 questions, and I'll explain you how to approach these questions, how to solve them. One more very important thing, that if you are preparing for CSI NET exam or GATE exam, then also you should watch this video. You'll be able to see new questions. You will be able to see how to approach them and how to solve those types of questions, right? And I would like to thank Karthik for providing the question paper to me. Thank you so much, Karthik. A big shout out to you. And one more important thing, that if you have not subscribed the channel yet, and if you are watching this video, please do consider subscribing it, because I usually made videos related to CSI NET preparation, GATE preparation, or all the competitive exam preparation related to your chemical sciences. Alright, so having said that, without wasting any time, now let's continue with our video. Okay, let's talk about this first question. It says that you are shown the following spectrum, but the units of the wavelength are missing. Which of the following answers is most likely true? Now here you are having a graph in which absorbance versus wavelength is given. Now it says that is it a vibrational spectrum of gaseous dioxygen, or is it a rotational spectrum of gaseous dioxygen, or it's a vibrational spectrum of gaseous carbon monoxide, or it's a rotational spectrum of gaseous carbon monoxide. Now one thing which you should know is this gaseous dioxygen, means O2. This is inactive in your rotational spectrum also and in vibrational spectrum also, because it does not have dipole moment, neither a temporary dipole moment nor permanent dipole moment. So it is inactive in both these cases. Now the only options are whether it is vibrational spectrum of carbon monoxide or rotational spectrum of carbon monoxide. Now vibrational spectrum, if you know, the vibrational spectrum with the different transition, it actually increases, it keeps on increasing unless and until you are given with a harmonic or anharmonic. That's a different thing. But what happens over here, you can see that the absorbance is actually increasing and then it is decreasing. So it's actually forming, or it's actually following a trend of something like this, which you might have seen graph similar to this. You might have seen when you studied the J max in the rotational spectrum. So this is quite equivalent to that, and that makes sense, and that makes answer as option number D, that this shows the rotational spectrum of the gaseous carbon monoxide, right? Because it is quite analogous to what we have seen in the J max graph. Okay, so the answer should be option number 4 here. Okay, the next question here, it says that the soft drink contains 11 gram of tartaric acid, and which is C4H6O6, and 20 grams of potassium salt, which is given to you as C4H5O6K per liter. What is the pH of the drink? Now to solve these questions, they have already given you Ka also. So I have solved this. I'll just take the reference of those and I'll explain you. Basically the formula which we use is pH is equals to pKa, and plus we have log and the concentration of base divided by the concentration of acid. Okay, this is the formula which we are going to use to do it. Now the base over here is potassium salt and the acid over here is the tartaric acid. So let's find out first of all the concentration of acid, and for that you need to find out number of moles per liter. That will give you, because the solution is in 1 liter, so moles per liter is actually going to tell you the molarity. So you just need to find out the number of moles, and that we can calculate by given weight upon molecular mass. Now the given weight is 11 grams, and the molecular mass over here, if you calculate for the carbon, hydrogen and oxygen, so the molecular mass will come out 150. And since it is for 1 liter, so you don't have to do it, but still you can just divide it by 1 liter. So basically it is going to give you 0.0733. okay, that's how much molar solution concentration will get for acid. Similarly, we will do it for base. For base, the value of the weight is 20 grams. The molecular mass which we will get over here, because potassium is also added and one hydrogen is removed, so it will be roughly around 188. Okay, and when you are going to solve this, so you will be getting 0.1064 molar. Now you got both the values, you have to substitute here. One more thing which you have to calculate is pKa. Now pKa is negative of log of Ka, and Ka value is already given to you, so you can substitute the value here. So it will be like negative of log of 1.0 into 10 to the power minus 3. Solve this and you will basically get 3. Now all the values I'm going to substitute here. What is going to be my pH? So pH will be equal to 3 plus log concentration of base, that is 0.1064, and divided by the concentration of acid, that is 0.0733. On solving all these things you will get 0.16, and on adding it with 3 it will become 3.16. So answer is option number 4, 3.16. That's the answer for. I hope you understood. Okay, the next question, it says that half lifetime of the first order reaction is dependent upon initial concentration of the reactant, and second says that the time required for the decomposition of 99% of 0.1 mole reactant undergoing the first order reaction is that much times to the half lifetime. Okay, so now let's try to understand it. First thing is half lifetime of first order reaction dependent upon initial concentration of reactant. So we know that T half for the first order reaction is 0.693 upon K, right? So it does not depend upon the concentration of the reactant as such. So first statement is false. So first option is wrong and option third is wrong. Either option 2 or option 4th is correct. Now once you calculate this 99.9% of 0.1 molar, and there is a direct formula also. Okay, I hope you all know that, but still if you don't know, you can just simply do it, that the time required for 99.9% decomposition. So the initial concentration you have to consider it as 0.1 mole, and the final concentration will be 99.9% of that. You can try it, you will get it 10 times. Okay, so just basic mathematics is there, that's why I'm not solving it. It's option number 2 correct for this particular question. Okay, fine. Let's take the next one. Here it says ki the sodium nitroprusside, that is SNP, given you in the form of Na2FeCN5NO, is used for the treatment of severe hypertension. It works by interacting with oxyhemoglobin, which results in release of cyanide and nitric oxide. Which of the following is not correct about SNP? Now first says that it is diamagnetic compound. Okay, fine. Next says that iron is assigned an oxidation state of +3. Third says it is a low spin complex, and fourth says that NO is a +1 in ligand. So let's write it down. So we have Na2 and Fe, then we have Cn whole 5, then we have NO, right? And you know NO has a positive 1 charge. So this statement is actually correct. Okay, so we don't have to do anything for that. So let's find out the oxidation state. So the overall oxidation state here, it will be like +2, and then you will have plus for iron I'm putting it X, then -5, then +1, it should give you 0. If you calculate it, X minus 2 will be 0, and the oxidation state which you are going to get will be +2. So the oxidation state for iron comes out to be +2. Here they are saying that iron is having +3 oxidation state. That's the wrong statement, and that will be your answer actually, because they are asking the incorrect statement, right? So that's the answer. But is it diamagnetic? So yes, it will be diamagnetic because it is iron in +2 D6 species and with a low spin complex because of the presence of a strong field ligand. So it will be diamagnetic compound, right? Okay, let's take the next one. Now this is regarding the amphiphilic molecules. It says which of the following statement is true regarding amphiphilic molecules. It says an amphiphilic molecule consists of both positive charge and negative charge. Second says amphiphilic molecule shows a spontaneous aggregation behavior in any solvent at all the concentration. Third says amphiphilic molecules are insoluble in water. Fourth says amphiphilic molecules are known to form liquid crystal. So first of all, you need to know what are amphiphilic molecules. Amphiphilic molecules are those molecules which have two you can say sides. One is water loving and one is water hating. So the best example of this is any sodium salt which you have seen. Okay, so let's say SO4 minus and Na plus. So this is sodium salt of fatty acid. It's basically it forms micelles, right? So micelles and all the polymers, whichever polymers are going to have two ends, one hydrophilic and one hydrophobic. So here this end act as the hydrophobic end, this as the hydrophilic end. So amphiphilic molecules are those which have two types of ends. those are called amphiphilic molecules. Okay, means one will be water loving, solvent loving, and the other one will be solvent repelling. Now, first statement which says that it consists of both positive charge and negative charge. So it is not necessary true. Let's say if I remove this Na plus, so will this particular will this particular salt or will this particular ion will be called as amphiphilic? So yes, then also it should be called as amphiphilic, right? Because it is again going to behave, this part is still water loving and this is water repelling. So it is not necessary to have a positive charge and negative charge both. Second statement where it says that amphiphilic molecules show spontaneous aggregation behavior in any solvent at all the concentrations. So no, it's not true. The concentration should be below above critical micellar concentration, and then only they are going to show this aggregation. For aggregation, the concentration should be above critical micellar concentration. So that is something which should be required. So that's why this is also not correct. Third says amphiphilic molecules are insoluble in water. That is totally incorrect. Amphiphilic molecules have water loving end, so that's why this makes it soluble in water. And the last statement which says amphiphilic molecules are known to form liquid crystals. This is the correct statement. Amphiphilic molecules form liquid crystals. The micelle is one of the example of that. There are various research papers which have been published for amphiphilic molecules and how they form liquid crystals. So yeah, option number D or option number 4 is the correct option for this. Okay, let's talk about this question here. It says that consider the following isotope exchange reaction being carried out in the closed container in the presence of catalyst. Now H2 plus D2 is giving you 2HD under high temperature limit. Which of the following statement is true about the value of the equilibrium constant KEQ for the above reaction? Now for this question, I cannot tell you that how to solve this because there are various ways of doing it, but there are many research papers which I have seen. So I can tell you the reference for this. Okay, I can give you reference for this, and the answer is that KEQ will be approximately equal to 4. Okay, so I'll give you research paper reference. You can see right now on the screen. That's how it is. So at higher temperature, you can see that the value of KEQ is reaching somewhere around 4. Okay, that is increasing. As you increasing the temperature, the value of equilibrium constant is also increasing, and as the temperature is higher, becoming higher, it is becoming closer to 4. So yeah, that's what it is. Okay, so let's go to the next one. It says one of the important chemical markers for the rise of oxygen concentration in the planet Earth 3500 billion years ago is the formation of blended iron formation rocks, जिसको BIF rocks भी is called. Okay, now can you predict what form of iron is found in these BIF structures given that the ocean pH is 8? Okay, so for this type you should know that what are BIF bands. I'll show you the image how it looks like. So basically the big rocks which have plates kind of thing or colorful bands over them, which is basically because of the oxidation of the iron which is present in those rocks. So that causes that band formation, and that is because of presence of two types of iron oxides. Those are basically your hematite or magnetite. Okay, so any of these are responsible for that. So hematite has a formula of Fe2O3, right, and magnetite has Fe3O4. So among these two, only this one is given. So answer will be option number 3 because of hematite. Okay, that's the answer. Okay, let's take the next question here. What it says that the correct combination of L1 and L2 among the following ligands that will satisfy the 18 electron rule for both metal centers in the following neutral molecule is. Now you just have to count for one of the ruthenium. So let's talk about this ruthenium. Ruthenium is going to give you 8 electrons. 5 electrons will come from eta 5Cp. Plus you will have this carbonyl which is going to give you 2 electrons. Plus you will get 1 electron from this metal-metal bond, right? So overall, if you add them, this will make it 16 electron species. Now you need 2 electrons more, right? 2 electrons more. So one should be coming from this ligand and one from this ligand. So that means the ligand should be able to give like 2 electrons this, like the ligand should be able to give 1 electron this side and 1 this side, and this one also 1 this side and 1 this side. Means you need both the ligands to be at least 2 electron donors, and those are carbonyl ligand which is 2 electron donor, and MECH2 minus is also a 2 electron donor. How does MECH looks like? So this is MECH. So it will bind to both these ruthenium something like this. Okay, to both this ruthenium like this, and CO will bind something like this. The rest of the complex will be something like this. Okay, so that's the final product which you are going to get after substitution of the ligand. Answer will be option number 3. Pretty simple. Okay, let's take the next one. It says that iron, cobalt and nickel are 3 known elements that display ferromagnetism. Which of the following statement is true about ferromagnets? It says that the presence of magnetic field, the unpaired spin of the ferromagnets all align with the external field. Then in the absence of external magnetic field, these spins then revert back immediately to their original state. This is not ferromagnetism, this is paramagnetism. Okay, so in paramagnetism, the species align their electrons according to the external magnetic field, and as soon as the magnetic field is removed, they will get back to their original positions. In ferromagnetism, once they align themselves, after removing the magnetic field, still they stay in the same direction. So that makes it ferromagnetic. So first statement is incorrect. Second says the origin of magnetism in a ferromagnetic arises from randomly aligned paired spin of lattice. That's again incorrect. It's not randomly aligned pair, but properly aligned. Okay, alignment in a particular direction causes the ferromagnetism. Third says ferromagnetic material is weaker in attraction to the external magnetic field than paramagnetic. It's again incorrect. Ferromagnetic substances are attracted more strongly to the external magnetic field as compared to paramagnetic. So all the 3 statements are incorrect. The correct answer is none of the above. None statement is actually correct for this. So statement or option number D is the correct option for this. All right. The next question was pretty simple. It says that the vapor pressure of solid and liquid ammonia near the triple point is given by this equation, and for this, so this is for solid and this is for liquid, right? We are given with the 2 equations. Calculate the ratio of slopes of solid gas curve and liquid gas curve. So basically you have to give the slope value. So the slope is plotted between the graph is plotted between log p by p naught and versus 1 upon t. That's how we plot the graph, and the equation which we are actually using here is log p is equals to delta h minus delta h divided by 2.303 RT plus C. Okay, that's the equation which we have. Now if you compare both of these things, so you will get slope for, let's say, solid, the slope will be 1630, and slope for liquid, according to the equation, I'm just taking the value from there, so that will be 1330. Now what you have to do is you have to give the ratio of solid gas curve and liquid gas curve. So just divide these 2 values. Okay, so ratio which they are asking will be like 1630 divided by 1330, and on solving this you are going to get 1.22, which is option number 3. Pretty simple and pretty straightforward solution. Okay, let's take the next one. The next question, it says that metal iron crystallizes in a cubic unit cell. The unit cell size is 287 picometer. The density of the iron is this much. How many iron atoms are there in 1 unit cell? Simple formula, simple question from solid state chemistry. You are given with the value of A, that is 287 picometer, or you can say this is 287 into 10 to the power minus 10 centimeters, right? And the density, that is rho, is given as 7.87 grams per centimeter cube. Now it's iron, so the mass you already know. For iron, mass is 56 grams per mole. Now you just need to put it in the formula of density. Density is equals to Z into M upon A cube into Na. So put all the values here and you need to find out Z here. Okay, everything is given, just put everything, calculate Z, and on solving you will get 2. Okay, so you will get 2 as the answer for this. All right, so I have tried to solve it. I'm not going to solve in front of you. I have already done. You can put the values and try it of your own. Option number 3 will be correct for this. All right, let's talk about this question. Here it says predict the most stable conformation of the following molecule called chems triacid. Now in order to write down their conformation, what you need to see is that the substitution is with the relative position of 1 3. So the positions are 1 3. Okay, now in order to find out, the groups looks like cis to each other, right? They are actually cis to each other. The methyl groups are also cis to each other, carboxylic groups are also cis to each other. So 1 3 says when you convert it in the chair form, it becomes either axial axial or equatorial equatorial. Now since you have to put both the groups over there, so that means there is no concept of axial equatorial here. So the same group will not go on axial and equatorial positions, which is you can see here it says that R1 is in the axial position and R1 goes in the equatorial position. So option 3 is incorrect. Same here also you can see R1 in the axial position and R1 in the equatorial position. Again it is incorrect. So third and fourth options cannot be correct. Out of 1 and 2 you have to choose. Now R1 being more bulky group should be on the equatorial plane, and R2 being less bulky group, it should be on the it can be on the axial position because the repulsion will be less when CH3 is there. Now the concept over here might be of the intramolecular hydrogen bonding that might come. Okay, so I'm not quite sure about this question as such. Those who are expert in organic chemistry, they can comment on this. So from my side, I think option should be like 1. But if the concept of hydrogen bonding and all comes for COOH, then it might happen that this on the axial position becomes more stable. That I'm totally not aware about. So this question I'll not consider as solved. I'll just keep it as a one which is open for discussion. Okay, so we can discuss down in the comment sections below. So for my side, but if I would be sitting in the exam, I would have given option 1 as the correct option. Okay, let's take the next one. Here it says given that delta H of the of an average value of minus 69.8 kilojoules per mole over the temperature range of 500 to 700 for the reaction described below. What will be the Kp at 700 Kelvin when the Kp is equals to this much at 500 Kelvin. So to solve this question, the formula which you are going to use is Clausius-Clapeyron equation in the extended form. So that goes like ln or you can just convert the formula in the terms of log itself. So it's like log Kp2 divided by Kp1, and this is equals to delta H upon 2.303 R, and in the bracket it should be 1 upon T1 minus 1 upon T2. So this is the formula which we can use, and you can try to solve it based upon it. Everything is given to you, T1, T2, and okay, so you can keep Kp1 is equals to 0.0408, and you can put temperature over here T1 as 500 Kelvin, right? And Kp2 you can put it as like that's what you have to calculate, and the T2, okay, this is T1, T2 will be 700. Delta H is already given to you, convert this in joules and then put, and R you have to put at 8.314. So on solving all these things, you are going to get option number 3 as the correct option. All right, so this is how this question needs to be done. All right, let's go to the next one then. Okay, now this question over here says that the gas of diatomic molecule in the thermal equilibrium at temperature T, if the potential energy of the bond of B between the atoms in the each molecule can be described by a harmonic form. The harmonic form is 0.5 into K B minus B naught square. Then the root mean square deviation in the bond length is, okay. So in order to solve this question, first thing which you need to see is root mean square deviation. Okay, root mean square deviation means they are talking about RMSD. Now this RMSD, the general formula of RMSD is sigma xi square divided by n, where n is the total number of particles and how it deviates. Okay, so anything like this is generally a value which is used in computational chemistry most precisely to understand how a molecule is shifting from its mean position or how the bonds are changing throughout the simulation. So that's a different thing, but fine, let's come back to this. For the given question, it's given that the potential energy, that means let's say U of the system, is given by 0.5 into B minus B naught square. Now this is nothing but the xi value only, means the bond length. We can consider it as xi also, and this is the internal energy of the system. Now I can convert this formula in this form as Ui is equals to like 0.5 into xi square. I'm just trying to make the formula similar. Okay, so this this thing is nothing but the distance, bond distance, so we can convert it in xi form. You can also take sigma in order to okay, we have K also here, right? So let's keep this K. Yeah, so yeah, here again we can put this sigma value. So this sigma will not be applicable on this and K, so that can be taken outside. So I will have sigma ui is equals to, I will have 0.5 into K and sigma xi square. That's what I'm going to get. Now the next thing which I can do is dividing both side by n. Okay, so I can divide by the total number of molecules. So that's what I can do. So here also and here also I'm dividing. Now this value, like total internal energy divided by n, is proportional to your kBT. Okay, so I can write down over here in the place of this kBT. Now here I'm using statistical thermodynamics to do it. So kBT will be equal to 0.5 into K, and this is nothing but, okay, and one more thing which you can do is taking under root both the sides. So you can just take, okay, let me first of all write down. So it's sigma xi by n, and taking under root both the side, this side and let's say this side. Now what do I get is this much value will be RMSD. So I can take this K to the other side. So what, and KB is a Boltzmann constant, 0.5 is a constant. So if I keep everything aside, I will just get T by K in the form of under root, and this is proportional to this value. That means under root of sigma xi square by n, which is basically RMSD. So what I can say is that root mean square deviation of the bond length is related to under root T by K. That is option number B. So option 2 is the correct option. Like that you have to do it. Okay, let's take the next question. This was a pretty simple one. It says predict and compare the thermochemical fuel efficiencies between the two rocket fuels. These are N2H4 and N2H2CH3 whole twice. Combustion reactions are given. Enthalpy of formation is given. What you have to do basically is you have to calculate delta H of both the reactions. This is calculated as delta H of product minus delta H of reactant. Now here you have product N2 and H2O are on the product side. The value of H2O is already given to you. Put the value here, and the reactant is N2H4 and your O2. So you can put all the values and just calculate your delta H. I have done it. Okay, one more thing, that for N2 it's not given. What is the value of delta H for N2? So let's consider it something as X, and for O2 is also not given. Let's consider it as Y. So on solving it, you are going to get the delta H for the first reaction as minus 292.6 plus X minus Y. This is the value which you will get for the first reaction. Similarly, when you do it for the second reaction, you will get minus 1030 and plus X minus Y. So that means the second reaction is producing more heat than the first one, and that makes the second fuel as more efficient fuel. So you can say that N2H2CH3 whole twice is more efficient fuel over N2H4. So that is how you can do. Okay, the next question is from inorganic chemistry, and that's from your organometallic compound. It says predict the product in the following reaction. The proton NMR spectral features. Symmetric compound. So the compound is symmetric, a singlet at aliphatic region for 3 protons. All aromatic protons are upfield shifted when compared to toluene. Now one thing which you have to see is you need to have a symmetric compound. So in among the given options, the one which is asymmetric is option number 4. So that's not a symmetric molecule, so you can cancel that out. Okay, now looking upon the other things, the option which follows 18 electron rule is your option number 2. Okay, that follows option number 3, it follows 18 electron rule. This is not going to follow because chromium will give you 6 electrons and you are going to get 6 electrons from the carbonyl ligands and 5. So this is just a 17 electron species. That's not stable, but here if you calculate, it will be a 18 electron species, which makes this more stable. And of course this is also unstable. So on the basis of stability also you can answer that option number 3 is the correct option. It is symmetrical, it will have a singlet in the aliphatic region, and all the protons will be upfielded compared to toluene because it is attached to metal. So toluene is there and they are upfilled because it is attached to the metal directly. Okay, let's take the next one. Now this question is from your analytical chemistry, and what it says is mixing of FeSO4 solution with NaNO3 followed by a slow addition of concentrated H2SO4 through the side of the test tube produces a brown ring. Among the following, the brown ring is due to the formation of. Now, this is a very famous reaction called as brown ring test. Now, this test is done to identify the nitrate ion. Okay, so this is done to find out nitrate ion, also called as nitrate ion test. Okay, so that's also one of the name which is given to you. And this is, yeah, this is used to detect the nitrate ion. The salt which is formed during this course of reaction is FeNO and H2O whole 5 and SO4. So that means FeNO H2O whole 5 should have 2 plus charge and SO4 2 minus. So that makes option number 2 as the correct option. So this is direct from our BSc MSc analytical classes. All right, I hope you understood. All right, now this was a trick question. It says that suppose you put 100 ml of water in cup 1 at 20 degrees Celsius and 100 ml of ice in a similar cup 2 at minus 20 degrees Celsius. Then you put both the cups in the microwave and heat them for 1 minute and then measure the increase in the temperature. Okay, which of the following will most likely to be true? Now the statements are like the temperature of both the cups would increase by equal amounts. It says temperature of cup 1 would increase more. It says temperature of cup 2 would increase more, and the third says that the answer cannot be determined from the given data. Now, to understand this, you have to focus on few things. They could have given anything to you, but they have given microwave, that you are heating in microwave. Now, why a microwave is given? Because they want to test your knowledge about the microwave and their action, how the heating happens in the microwave. So microwave is not like your regular gas stove, and it does not heat the system through conduction, but it heats the system through the electromagnetic radiation. So the particles, let's say this is a particle, the microwave are going to give energy to this particle so that it can rotate, it can vibrate on its own place, and that energy it can absorb, and in that way it it gets heated up. Okay, so there are different motions in the bond which can be caused for the molecule. Basically in the microwave region the molecule will rotate, right? So the rotation of the molecule will cause heating, and that heating is going to that heating will be because of the friction and the viscosity of the substance, and that's how it heats up and that's how it get cooked. Now when you are talking about ice, okay, so in ice there is something which we called as hydrogen bond, right? We all know about that. So the water molecule are attached to each other through hydrogen bond. So these microwave, when they are going to come and they are going to touch, or they are going to pass through those hydrogen bonded water molecule in the ice, they will not be able to rotate that bonds or rotate that molecules. Why? Because they are so tightly bound through that hydrogen bond that they are not, that microwave will not be able to produce that much energy to rotate them. Okay, and that's why the heating effect on ice is not that good. That's why the substance which is frozen, let's say if you have microwave, you might know about this, that frozen items or frozen food items, they cannot be directly kept into microwave because the microwave cannot work that efficiently for them. So first of all, frozen items are kept outside so that they come to the normal room temperature, and then they are kept in the microwave so that they they can be cooked. So microwave action was the key to solve this question. So that means the cup 1, which is where we just have water, so that will absorb microwave and it will raise its temperature. But the cup 2 where ice is there, so ice will not be able to raise its temperature because the microwave will not be that efficient to rotate the bonds and cause the heating effect over there. So the temperature increase will be more in cup 1, not in cup 2. So that's why option number 2 is correct, that the temperature of cup 1 would increase more, not the temperature of cup 2. Okay, so I hope it makes sense and you understood. Okay, the next question was based upon your John-Taylor distortion, in which it is not observed. Pretty simple and straightforward. D5 high spin complex, because it has symmetrical electron filling, so all the electrons and all the orbitals are symmetrically filled. No irregularity in the electron filling, that's why no John-Taylor distortion. Okay, let's take the next question. What it says that equilibrium constant of the reaction is described by this. Kp is given to you as 10 at 960 Kelvin. In which direction the reaction will proceed spontaneously for? So you are given with the overall reaction. So first of all, you need to calculate the Q for this reaction. Okay, because yeah, so that will be like SO3 square, and divided by, you will have SO2 square and O2. Now, since they are giving everything in the form of pressure, so you can put the values. So it will be 1 into 10 to the power minus 4 and divided by 1 into 10 to the power minus 3 ka square and multiplied by 0.2 bar. Everything is in bar, so we don't have to do anything. On solving this whole thing, you will get 0.05. So you can see that Kp is actually greater than Q, and if this happens, the reaction proceeds in the forward direction. Okay, this is the condition for the forward direction reaction. So forward direction means reaction will proceed from reactant to product. That's your option number 2. So option 2 should be correct for this. Okay, let's take the next question. This is again a good question. It says, following are the 4 isomeric square planar complexes formed by the reaction given below, and what they are asking is identify the chiral compound. So option 1 is a chiral compound because it does not have any axis. You cannot, sorry, it does not have any plane of symmetry. Second also does not have any plane of symmetry. Third one has a plane of symmetry. I can draw that plane of symmetry something like this, so that bisects the molecule into 2 equal half. And fourth also has this plane of symmetry. So third and fourth are achiral. Okay, these are achiral, third and fourth, whereas first and second are chiral. Option number 1 is your correct option for it. Let's go to the next one. Okay, this was again a very good question. It says that in a new temperature scale, delta H, the melting point of hydrogen is 0 degree H and the boiling point is 100 degree H. PV is 28 decimeter cube ATM at 0 degree H and 40 decimeter cube ATM at 100 degree H. What is the value of absolute zero in the given temperature scale? So how to do this question? First of all, you need to see that when you are having yeah, so when you are having T is equals to, let's say, 0 degree H, your PV, okay, I'm writing the value of PV is 28 decimeter cube ATM. I'm not writing the unit here. And when it is becoming 100 degree H, and that time it is becoming 40. So you can see when I'm changing my temperature from 0 to 100, that means 100 degree H change in temperature is causing only 12 unit change in PV. So what I can say is delta T, when I'm making delta T is equals to 100, the change in delta PV is only 12. So I can calculate that what does my 1 PV is going to cause, right? So 1 PV change can be equal to, in the terms of temperature, will be 100 divided by 12. So that is the value which 1 PV is going to cause. Now, in order to come to absolute zero, since at 0 degree H, our PV is 28. Now, if PV becomes 0, because you know PV is equals to nRT. So, at absolute zero temperature, your PV will also be 0. So, that means in order to make this PV 0, that means at absolute 0, okay, at absolute 0, what is going to happen? My PV should also be 0. And in order to make PV 0, I need to change 28 units in PV. Okay, so I need to make PV is equals to minus 28 units. Okay, minus 28 units. Unit is decimeter cube per ATM, decimeter cube ATM. So since I know that 1 PV is equals to this much delta H, so I can now substitute its value here. So minus 28 into 100 divided by 12 delta H. Solve this, and on solving this, you are going to get minus 233.33 delta H. So option number 3 will be your correct option, and this is how it needs to be done. I hope you understood how to do it. Let's take the next one. What it says that given the compound over here is FeSO4 NH4 whole twice SO4.6H2 and compound 2 is K4FeCN6. When it is dissolved in water, the following is correct. Okay? It says both the compounds give positive test for iron plus 2. Only compound 1 gives positive test for iron plus 2. Only compound 2 gives positive test for iron plus 2. And both do not give usual test for iron plus 2. See, the first one has iron in the ionic form. So it can dissociate and it can give you Fe plus 2. Whereas in the second one, the iron is in coordination sphere. Now, if you have studied coordination chemistry, very basics, it says that the coordination complexes are those which does not breaks or which does not dissociate in the solvent. So if you put it in the solvent, it does not dissociate easily. These are called coordination compounds, and here it is in the coordination sphere. That's why it will not give you iron plus 2 test. So the only compound that gives you iron plus 2 test is compound 1, because here iron is in the ionic form, not in the coordination form. All right. So this was just from class 12th basics of coordination chemistry. All right, let's take the next question. Here it says that a particle with energy E is incident on the square barrier with height h, which is greater than E, and a width w. Which of the following statement is correct for the particle after the quantum mechanically tunnels through the barrier? Okay. Now it says that the particle has energy E after tunneling through the barrier. It says energy of the particle decreases as W increases, but it's independent of H. The energy of the particle decreases as H increases, but is independent of W. That means the width. The energy of the particle decreases as H and or W increases. So basically you have to go through a square barrier concept. So if you have a square barrier and if your particle is forming wave like this, so here exponential decay in its curve happens, and here you get the particle with stronger smaller wavelength and all. So the energy decreases for the particle. So the energy of the particle does not remain same. Second thing is that the formula for tunneling is e to the power minus 2 under root, it's 2m, it goes like v minus e divided by h cross and l. Now l is the length, v is the value of potential here, that is height over here, and L is the length. So anything if you increase, either if you increase the height or if you increase the width, okay, anything if you increase for the system, the energy of the system or energy of the particle is going to decrease, and the tunneling will become impossible as or it will become difficult as you increase the height or if you increase the width. So the basic idea between for the compound or for the molecule to do tunneling is that the tunnel should be or the barrier should be thin, okay, and it should not be infinite, it should be finite barrier. So option number 4th becomes our correct choice for this. Okay, let's take this one. This says that consider a coin with two sides, h which is heads and t which is tails. The probability of observing h h h h h t t t t t is equal to the probability of observing h t h t h t h t. Okay, fine. And second statement says that for a system of equilibrium, Gibbs free energy is maximized. Now this thing you all know that at equilibrium what happens. So at equilibrium your delta G is 0. So it's not maximized, it's minimum. So statement 2 is false. Statement 2 is false. That means answer number 2 is incorrect and answer number 4th is incorrect. Either 1 or 3 is correct. Now talking about the first statement, you can see that for getting a H, your probability is 1 by 2. And since you have 1, 2 or for tails also the probability is 1 by 2. Now since these are like dependent observations, because whole is going to make the complete observation, right? So you have to multiply their individual probability. So once you multiply half, like you have to multiply 10 times, because for heads and tails it's same. So for H, T, it will be like 1 upon 2 raised to the power 10. Okay, so that's going to be the probability, like that's going to be the probability of that. Similarly, when you are going to do for HT, the same thing will be observed here. So HT, again same, like half for H and half for T, 10 times they are, so again same thing. So the probability of observing both of them is exactly same, which is why option number 1 or statement number 1 is the correct statement. Okay, let's see the next question. It is very good question. It says consider a particle which is confined in one dimension. The following graph displays the position of particle as a function of time. Now one thing which you can see is the position is changing in the same pattern, but the only thing is the magnitude of change in position is less here and then it is more here. So that means if you are trying to find out the velocity, they should also follow that same pattern. See, it is increasing here also and here also. So that means the velocity should follow the same pattern here and here. But here you can see the velocity is following the reverse pattern. Here it is different shape, and that shape is reversed here. So that's why first is not correct. Same goes for option number 2, that is also having reverse structures, right? Reverse shape. That's also incorrect. Now this can be either option number 3 or 4. Now initially if you see, the velocity is increasing, because as the position is increasing with time, velocity will increase, right? When the position or the distance increases, velocity, because you know velocity is equals to dx by dt, that means change in distance by time. So as the x increases, your velocity also increases. So that means initially it should increase and then it should decrease, right? And at this mean point it will be 0, because here the particle, there is no change in the the position is not changing, so that will be this mean point, and then it will decrease. So that's going in this direction. That makes option number 3 correct. So see, initially it is increasing. When your particle is in this region, the velocity will also increase. When it is coming down, the velocity is coming down again, okay? And then again it is reaching to a mean position, and that's where it's coming back to this particular position, right? Because now your body, although it seems that the change in distance is 0, so the velocity should be uniform, but according to the initial position, it is actually like getting back to its position. Then again it's again increasing here, right? Yeah, again it will be having similar pattern. So you can see same pattern it's following, but with a longer magnitude. So option number 3 is the correct option for this. So that's how this will be done. All right, let's take the next question. It says predict the aromaticity of the following molecule. Pretty simple. You know this is going to be aromatic. Why? Because 6 pi electrons. Here you have just 4 pi electrons. That makes it anti-aromatic or anti-aromatic, right? And here again in this you can see 1, 2, 3, 4 pi electrons, and 2 pi electrons will come from this lone pair of electron of nitrogen. So this is again aromatic, which makes option number 1 as your correct choice. Aromatic, anti-aromatic, and then again aromatic. Okay, the next question, it says that the correct order of molar extinction coefficient for the electronic transition in. So molar extinction coefficient, that means like you can say the absorptivity is proportional to the intensity of transition, okay? And the intensity has a particular order. What's that order? सबसे पहले you have to see the charge transfer, okay? The charge transfer spectra. So the charge transfer spectra has highest intensity. Then comes your tetrahedral arrangements, the arrangements which are tetrahedral. Then comes your distorted octahedral, means those which are having John-Taylor distortion. And the least ones are your like perfect octahedral, the one which does not have John-Taylor distortion, those octahedral. Now if you look upon, so MnO4 minus will have LMCT, because manganese over here is in +7 oxidation state. So this MnO4 minus will have ligand to metal charge transfer. Talking about your MnH2O6 + 2, this is a D5 species in high spin. So this will not have, like, it will not have any John-Taylor, no John-Taylor distortion, okay? Now talking about titanium H2O6 + 3, so here your titanium is in D1 system, high spin, so it will have weak John-Taylor distortion, although it is weak, but it will be there. So if you have to write down the order, so charge transfer will have highest intensity, that means your MnO4 minus should have highest. Then among these two, the John-Taylor one will have higher one, so TiH2O6 + 3, and the least one should be the regular octahedral, that is your MnH2O6 + 2. That's your option number 4th. Okay, so option 4th is the correct option for this. Okay, let's see the next question. It says following is the energy level diagram of the molecule. Each group 1, 2 and 3 depict the optical transition which ultimately returns to the molecule to the ground state. Now you need to note that first and second consist of 2 transitions, whereas third consists of 3 transitions. Which of the following depict the right time scale of the processes? Now you need to see that S0 is the ground state, S1 is the first singlet excited state, T1 is the first triplet excited state. Now this dot dot dot, it's some imaginary state, or you can say intermediate state. Okay, intermediate state. Now one thing which you need to know is there is no stable state between S0 and S1. Okay, so these two are most stable states. In between them, any intermediate state is not that stable. So talking about that, we'll come back to that later, but what you have to see is the third one is undergoing inter-system crossing, and then it is going to the triplet excited state and coming back to the ground state. This is nothing but this is phosphorescence, and the second one is your fluorescence. Now you know that phosphorescence is a delayed process, or it takes more time to take place. Fluorescence is a pretty quick process. So the third one should be slowest, and the second one should be should be faster than that. So third one should be slowest. Okay, third one cannot be fastest. Is there any third one is fastest? There is no option which says third one is fastest. But yeah, third one is slowest is there in option number 3 and 4. And about 1 and 2. So now let's talk about the first one. First one is going to some intermediate state, and it's going to that intermediate state and coming back. So the intermediate state is not at all stable. So it will quickly go to there and it will quickly come down. It's not a stable state. So the particle or the electron or the whatever system is undergoing this transition will not be stable over here. So as soon as it reaches to that state, it will again, or it will quickly come back to the ground state. So the fastest among all the three should be first. So first is going to be the fastest one, third is going to be the slowest one, and second should be intermediate. According to me, answer should be option number D for this. Alright, let's take the last question for this video. It says, two students named A and B repeatedly measure the volume of the solution consumed in the titration experiment 10 times and 4 times. They report the following result. These are the results given. Which of the option openly or correctly represent the fractional uncertainty in the average? Now, first thing is to calculate the average. Now, average is pretty simple. You know, average is calculated as sigma xi divided by n. You just have to sum and divide it by total number. So once you do it for this, for A, let's say for A, the average will come out 20.3. That will be the average value. And how to find out uncertainty? So uncertainty is basically the maximum value minus the minimum value divided by 2. That gives you the uncertainty value. So here if you see for A, the maximum value which it reaches is 21 and the minimum value is 19.4. So if you do that, so 21 minus 19.4 divided by 2, divided by 2 should make it 0.8, right? So 0.8 is your uncertainty over here. So the average will be written as, or overall you can say the reading according to A, like student A should be written as 20.3 plus minus 0.8. Okay, now talking about B, when you are going to talk about B, here if you want to calculate average, the number should be 4 only. The total number in this case it was 10, but here it should be 4 because only 4 readings have been taken. So for B, when you calculate here also you will get the average over here for B. Okay, for B, if you calculate, the average will again come up 20.3 only, and if you calculate the uncertainty, so the maximum value is 20.9. Yeah, so 20.9 is the maximum value, minimum is 19.9. So 20.9 minus 19.9 and divide it by 2, so that will give you 0.5. So the reading taken by B should be written as, okay, I will write down it here. So it should be written as 20.3 plus minus 0.5. Now this is the actual values which we have. The fractional uncertainty is calculated as the uncertainty divided by the average into 100. But if you do that, you are not getting actually any of the options. Okay, try to do it of your own, but that will not give you any of the options. What I believe is they might have just taken these values and they have taken, like, you can, that's what is getting as the answer, right? If you just take them, so it becomes option 1 as the correct one. That's the most probable answer which I think should be there. I guess I'm missing out something. The the comment section is open for debate over on this particular question. You can give your input to this, how to solve this. But for now, or for me, I think answer should be option number A. Is there any other method? Yes, it may be, and fractional uncertainty should be calculated. So I think I'm missing out on this. If I will find out the solution, I'll definitely let you guys know. But that's it for this video. So we have solved all the questions which I knew. I think around 30 or 31 questions we have done in this video. I hope you guys understood how it is done. There are around 7-8 questions which are left out, which we didn't discuss in the class. They are majorly from the organic portion. Some physical chemistry questions are there which I'm trying to get a correct answer out of it. If I will get, I will let you guys posted on the community tab. So that's it from my side for this video. I'm recording this very late in the night. It's around 2:30 a.m. So yeah, thank you so much for watching the video. Thank you so much for looking into it. I hope you guys loved it. I hope you guys understood. And that's it. I will see you in the next one. Till then, have a great day. Bye bye. Take care. Hey guys, so I teach live on Unacademy Plus platform. Here I teach for the CSI UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Unacademy Plus subscription. So do make sure that you take the Unacademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Unacademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.